if it's talking about a base, it's going to contain a lot more OH than it will H plus. Okay, number 5. Which compound reacts with an acid to form a salt and water? Didn't really get to this yesterday. Did anyone figure it out? It has to be a base. Very good. What's that? Yeah, you're right. When we talked about neutralization reactions, we said an acid plus base forms a salt and water. So you have to go to your reference table and pick the base out of those. Now, there is a little trick here. They love to confuse people by putting an OH like this and having people pick this as a base because they see the OH and they say, base, OH. What is the difference between this CH3OH and this KOH? One is ionic. Very good. Bases will always have a metal involved unless you're talking about ammonia. Bases will have a metal. This one right here is actually not a base. Anyone know what it is? Not an acid. An alcohol. We haven't talked about organic chemistry yet, but when we get into that, you will discover that alcohols will contain an OH, but they won't contain a metal ion. And so that's what they like to confuse you with there. Anyways, KOH, that is our only base. Number 6. According to the Arrhenius theory, which list of compounds includes only bases? Pretty easy if you go to your reference table. What table are you looking at? Good. Table L. That lists your common bases. The only one there that's not listed is LiOH. It is also considered a base. Anything with group 1 and OH is considered a base, but that's how you pick those out.
They all contain OH though, so how do you...
Sure. This one here doesn't have a metal, so that disqualifies it. This one here doesn't have a metal, disqualifies it, and that one contains an acid. Good question. Well, actually, I was trying to record the homework because I thought Mitch would be able to benefit from it. Number 7. Let me just see something real quick.
Mr. Cook, did you ever get a chance to change my grade?
Hold on just a sec. It's not saved, but I will make sure it gets saved.
I'm an 88 in Oh, I have a 0.
There we go. Okay.
Well, it's been recording for 3 minutes.
I'm hoping it recorded the right thing. We'll have to check that.
I listened to him last night.
Number 7? Yeah. Number 7. According to the Arrhenius theory, when an acid substance is dissolved in water, it will produce a solution containing one kind of positive ion. That's an easy one. It's going to be a hydrogen ion. Number 8, in an aqueous solution, which substance yields hydrogen ions as the only positive? Pick the acid out. Go to table K. The only acid here is the acetic acid. Don't get fooled. That's ethanol. What's ethanol?
Alcohol.
Yep, drinking alcohol. Or what they call grain alcohol, same alcohol that's burned in cars for fuel, racing fuel. Number 9, the only Arrhenius base is B. Did anyone get fooled and try to pick? No, that one's pretty straightforward because there's no other OHs. Number 10, when an Arrhenius base is placed in H2O, the only negative ion present in the solution is, pick the hydroxide. Number 11, Which 0.1 molar solution contains the highest concentration of OH negative ions? That would be NaOH. You got it. And now I don't have your remaining problems. So, could I borrow someone's?
I don't know. Probably not very, but.
It's all right. Don't.
Yeah,
We will
probably
self-correct
really
here.
wrong.
Number 13.
Oh,
What is the pH of a solution formed by neutralizing 50 mL of 0.1 molar HNO3 with 50 milliliters of 0.1 molar NaOH? So what you're doing here is you're taking equal concentrations and equal amounts of a strong acid, nitric, and reacting it with a strong base. So you're going to form what type of solution? Acidic, basic, or neutral? Neutral. So you are going to want to pick right there a 7 for pH. Pure water at 25 degrees has a pH of, if it's pure water, it will be neutral. So again, 7. An acidic solution could have a pH of 3. Good job. And if the H3O concentration of a solution increases and the OH negative ion concentration decreases, the pH of the solution. So the H plus ion concentration goes up. The OH goes down. Which way on the pH scale are we going to go? We're going to become more acidic, so that means we're going to drop and we're going down. And this looks really good. Thank you, Haley, for doing this. Naming your acids and drawing how they dissociate. Hydrochloric, nitrous, nitric, sulfurous, sulfuric, phosphorus, carbonic. The only thing I would do different here is I would just show the dissociation going the other way. So I'd write the HCl and break it apart into H plus and Cl negative. Start with the acid, turn it into the ions. So all you have to do there is put this as your reactant and then write your H plus Cl negative. So yes, these look awesome. You can check them out, but just again, reverse the arrows on your guys's.
Why do you have to reverse them?
Because when they dissociate, it means by definition breaking into ions. You have the ions forming the acid or base. You want to form the ion. So that's why you just write it in the reverse direction. NaOH yields Na plus, OH negative. Questions on any of those?
This is a grade, right?
I need to give you a grade. I haven't yet.
I got Can I go to the bathroom?
Yep. Thank you, Kaylee. Okay. I need to know who did not get it done. Got it?
Me? Yes.
Everybody? Sweet. Okay.
I got like 50, no, like 60% of it. Like,
Well, there were a couple there again that we hadn't quite gotten to, so.
oh dear. So you know it's really out of time.
Thank you.
Hey, you know what? That video really helped me out.
Did it really? Good. Other people actually said that that helped
I've
being
been
able to
watching
rewatch
them.
it. So
Are you gonna name this one after?
yeah, I'll do this acids and bases too, since we really didn't put one up yesterday. Okay. We are going to talk here real quick about what is called the auto-ionization of water. To try to kind of do a better job at understanding the pH scale. So the auto-ionization of water can be written as follows. If you take one water molecule and you react it with another water molecule, you end up getting the hydronium ion, H3O plus aqueous, and OH negative aqueous. Yep, both those are both liquid. Sure can. I'm might be too much, but we'll see.
H3O.
H3O plus, and we said the H3O plus ion, we gave this a term, and we said that is going to be called the hydronium ion. And we said, what is it equal to? Very good. It is equal to a proton, or a hydrogen ion is the other way to call H plus. Now, this autoionization equation sometimes can be represented like this, and it just shows the breaking apart of water into H plus and OH negative. So these two are really expressing the same equation. So here's what is interesting. We said that water is covalent at the beginning of the year because we said it obviously contains no nonmetal. All right, no nonmetal is there. Sorry, no metal is there. But here's what's interesting is that pure water actually does have some ions present. It has protons present at a concentration that is very, very small, 1 times 10 to the negative 7th molar, and it has hydroxide ions present, also in a very small concentration, 1 times 10 to the negative 7th molar. So what it means is that this equation, the equilibrium lies way over here to the left, meaning at equilibrium you don't get very many of these ions at all, a very small amount, because that's a very, very, very small number, 1 times 10 to the negative 7th. But in pure water, it's important to recognize that the concentrations, those two numbers, are equal to each other. And when that occurs, we have a neutral solution. It's also important to understand that these two species, H plus and OH negative, are interdependent. So what that means is as H plus increases, OH negative is going to decrease. And the reason why that is true is what is called the autoionization Kw equation. And it's represented by this. H plus times OH negative, and again, brackets mean what? Concentration. What's that, Zoe? Oh, it is. You're right. H plus times OH negative is equal to Kw, and Kw is given a value of 1 times 10 to the negative 14th. So H plus times OH negative is equal to Kw, equaling this value of 1 times 10 to the negative 14th. This has no unit, but these are going to both be in molarity. Good question. Okay, so now this is kind of easy now to understand why both of these are 1 times 10 to the negative 7th. Because if in pure water these are equal, it's like saying this. X times x, or x squared, is equal to 1 times 10 to the negative 14th. And if you take the square root in order to solve for x, you will get 1 times 10 to the negative 7th molar. So what this shows us is that in pure water, the two values of H plus and OH negative have to be equal to each other. Okay, they have to be equal to each other. Now, let's do a quick example to find out if you have, for example, a solution where H plus is not 1 times 10 to the negative 7th. Could you find the concentration of the other species, hydroxide? So here's the example. If H plus is equal to 1 times 10 to the negative 10th molar, find the concentration of hydroxide. If H plus is equal to 1 times 10 to the negative 10th molar, find the concentration of hydroxide. Cassie.
How does doing the square root of 14 make it 7?
Yep, great question. So when you have 1 times 10 to the negative 14th, when you multiply, I'm going to go back up here just real quick to show you this expression. If I told you, Cassie, right here, if I said multiply these two numbers together, what you would do is you would end up adding negative 7 plus negative 7, and you would get negative 14th. So when you take the square root of 1 times 10 to the negative 14th, it takes you back to 1 times 10 to the negative 7th. So you're multiplying negative exponents to get 1 times 10 to the negative 14th, so when you take the square root, it takes you back to give you just the one of them. Good question. If H plus is equal to 1 times 10 to the negative 10th, find OH negative. Here's how you do it. You're going to say H plus times OH negative is equal to 1 times 10 to the negative 14th. We're going to plug in what we know for H plus, which is 1 times 10 to the negative 10th times OH negative is equal to 1 times 10 to the negative 14th. If it is impure, if you're talking about a pH of 7, it will be the same concentration. But this now is going to be talking about a solution that does not have a pH of 7.
Yeah.
Hold on, I haven't done it yet. We haven't solved for this. This is our
Yeah,
variable
but where'd you get the number for H plus?
right here.
Oh, okay.
Does that answer your question? You said you didn't know where I got the number what?
No, I don't know how you got 1 times 10 to the negative 14.
Good question. You're always, by definition, going to set H plus times OH negative equal to this constant called Kw, and that is the value 1 times 10 to the negative 14. So that is a constant that you'll always use in these problems, 1 times 10 to the negative 14. So now what you're going to do is you're going to solve this expression for your unknown, OH negative. So we have to divide both sides by what? Yeah, you're right. 1 times 10 to the negative 10th. Divide both sides by 1 times 10 to the negative 10th. And here's a beautiful thing. When you have a base of 1, it makes it really easy because now you're going to take negative 14th minus 10. Okay, so when you take negative 14th minus a minus 10, why is it minus a minus? Yeah, you're dividing. So you're going to take your negative exponent on the top, minus a minus, and you will get 1 times 10 to the negative, Zoe, 4th molar. And that is equal to the concentration of the other species in this equation, which is OH negative. So you can always find one if you know the other.
So like if
Okay.
you wanted to like check yourself, you know that OH has to be less than H plus, right?
Very good. You know that if H plus is 1 times 10 to the negative 10th, you know that in this case, because they have to be multiplied to give you 1 times 10 to the negative 14th, this has to be less. You got it. So this allows us to find either H plus or OH negative, and where this is going to come in useful tomorrow is we're going to learn how to calculate pH using the logarithmic scale. So how many people have done logs recently in math? Log base 10. So I'm probably going to have to remind you or refresh you of how to use logs, but that's what we'll do tomorrow. Alrighty. Homework tonight is section 19.1, page 593. Section